Well, I hope everyone is having a fine and wonderful weekend. I'm going to dive into a couple of parallelogram examples, but first I want to point out the parallelogram definitions that we're going to be applying with. And again, the best way to learn these is to actually practice them in specific problems. Now for parallelograms, we have opposite sides equal, opposite angles are equal, consecutive angles are supplementary. In addition, the diagonals bisect each other. Let's go ahead and take a look at a couple of quick examples that help us learn these definitions. Here we have a quadrilateral, and basically we're going to solve for a, b, x, and y. So the x and y are the angles, and a and b are the sides. Using our definitions, opposite sides are congruent. We know that this is going to be 15, and this one is going to be 8. Now, given parallel lines, we have parallel line here and here. We know that opposite angles are, alternate interior angles are going to be the same, so that's going to be 30 as well. But that doesn't really help us on this particular problem, other than the fact that we have 80 and 30. We know that these right here, same side interior angles given parallel lines, have to add up to 180. Well, if this is 110, this has to be 70. And this is going to be 70 also. So I'm just filling everything out. And guess what? If this is equal to 100, this whole thing right here is 100. So we know that the big angle is 100, so this big angle right here has to be 80. And that pretty much knocks it out. Same side interior have to add up to 180. Remember, this is the big angle right here. These two don't add up to 180. That's a big common no-no. The whole thing has to add up. These two right here have to add up to 180. Let's take a look at the next example. Now, you've kind of seen this before, so what we have is a parallelogram, and let's go ahead and find one, and we draw a picture. So there's a picture, and we're just going to start filling it out. So I have A, B, C, D, so A, B, C, D. Now this is very important. A touches B, B touches C, C touches D, so I did it all in order. And the diagonals look like they, oh man, that was just so way off. Diagonals intersect at E. My equation, which I'll just write down here because I have tons of space, is AB is 3x minus 6, 3x minus 6. BC is 5x. CD right here is 2x plus 5. So I want to just go ahead and fill all this out. Parallelogram, opposite sides are congruent, so I'm just going to write 3x minus 6 is equal to 2x plus 5. Opposite sides are congruent. Subtract x on both sides and add 6, so I get x is equal to 11. And I'm going to plug that in. So x is equal to 11 right here. Because we want to find the perimeter. The perimeter is all these things added up to this. So this side is going to be 5 times 11, which is 55. And this side is going to be 2x plus 5, so that's 22 plus 6. 22 plus 5. Good grief, I can't even add, which is 27, right? 22, see, 2 times 11 plus 5 is 22 plus 5 is equal to 27. So this side's 27, this side's 27. So my perimeter is nothing more than 27 times 2, which is 54, plus 55 times 2, which is 110. So that's going to be 164 units, whatever they are. Okay? That pretty much does it. I'll have some other type of examples coming up shortly.